Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This time I'll talk about my CPU's logic boards and debugging thereof, segmented memory on Regal scopes, clipping of silkscreen when having a PCB made, do-it-yourself PCB stencils using laser cutting and removable label sheets, the Gigatron homebrew TTL VGA computer, failure while testing a LED driver, and software I didn't make. Right, first let's introduce the new co-host. That's right, because there is no co-host, it's just me. What I did last week I think, I'll talk a little bit about that. It shouldn't be very long, between 5 and 10 minutes. So I'm still making logic boards for my CPU project, which I want to show at Maker Faire Dortmund in March. I finished all the logic boards. There are 4 logic boards, the multiplexer, a latch board, the increment board and a digital I/O latch board. And 2 of them are received, 2 are still in the mail. I have replaced the original 2 boards with the new ones, assembled the new ones and replaced them, swapped them around with the old boards, and the CPU didn't work anymore, so that was not optimal. So I started debugging a little bit. I found a problem, it's not very interesting. It had to do with different threshold voltage levels from the different modules. It's all going to be fine. However, while debugging I found an option on my scope, which is the Regal DS154Z 4-channel scope, which I rarely use, and it was waveform recording, it is called by Regal, and normally it's called segmented memory. So that basically means you can record, let's say, 1000 or 100 events spaced very far apart. So if you can record 100 trigger events, even though there's a lot of dead time between those events. So that was very nice for debugging what I did here. So you can scroll through the events and ignore all the dead time between events. So that's very good use of scope memory. Saves me a lot of time. What I did here was somewhere in between using a scope without segmented memory and a logic analyzer, and at some point I would like to try a logic analyzer. I tried one, it was the Sealy logic analyzer a long time ago on a Linux system that worked reasonably well. Someone else had suggested also a logic analyzer, so maybe that's worth looking into. I have a Bus Pirate, I think that has a logic analyzer option as well, but I don't really trust that for that kind of stuff, so maybe I invest into something that's a bit nicer. Anyway, while making the PCBs for that CPU, I stumbled across a little problem, where silkscreen was clipped against copper pads with a little bit clearance around it. Now normally that's not a big problem, because if you have a line crossing a copper pad, for example, where on the silkscreen crossing a copper pad, where the silkscreen line would intersect the copper pad, the line is simply cut away. That's not a big problem. If you have thin lines or text or something like that, usually it's not a problem. However, on this board I had pretty thick lines, for 0.5 millimeter or 1 millimeter thick silkscreen lines to make an actual drawing. And even if you have 1 square micron of overlap with a copper pad, not just a copper pad, but copper pad plus clearance, 0.2 millimeter clearance in my case, then the whole line is clipped. So not just 1 square micron is clipped out of the line, is removed from the line, the whole line is interrupted at that point, and you will see a 1 millimeter thick line with a gap out of it, right? So usually I get my PCBs from Eurocircuits in Belgium. I know it's not the cheapest one, but they're very fast, it's super quality, so as long as I can pay that, I'll continue to get my PCBs there, I think. I looked around a little bit for getting PCBs from overseas, but although the price is ridiculously low, the time it would take to receive them is just too much. So I don't have the patience for that. So I think I'll continue with Eurocircuits. However, one thing to save money is stencils. Now, if you order a stencil for every single PCB that you make, that's what I normally do. then that will cost somewhere around €35 per stencil. And if you have a PCB just to test something, it gets a bit ridiculous. So for these 4 I/O boards that I did just now, it would be €140. That's a bit ridiculous just for stencils. Now, a few years ago, I had to make a fix PCB to fix an existing problem. And, well, first of all, I never ordered a stencil, so this was not going to be the first time. What I did instead was take a removable label sheet. That's basically paper with a sticky backing. The point is that you can remove it without leaving any residue. The paper itself is about, I think a little bit less than 100 micron thick, but it's not a big deal. So what you can do is take it to a laser cutting machine, export the base layer from a PCB to a DXF file, input that in the laser cutting software, cut exactly those holes out of the paper, stick it on your PCB, apply paste in the holes, remove the removable label sheet, and your paste is exactly in the right spot. Now that works reasonably well. So usually I use 0603 components for passives, and TSSOP or TQFP, that's 0.65mm pitch. That works reasonably well with a little bit of luck. So anything smaller is probably not going to work very well, and I wouldn't do this for a QFN or something like that. But in a pinch, that's really easy. Just remove like a disposable removable stencil, right, for one-time use, obviously. And I did the I/O boards using this kind of do-it-yourself stencil, and it worked very well. So I'm very happy with that. Also, on an invitation by someone else, I went to visit a hack space, something like that, called the Rev Space in the west of the Netherlands. Never been there, so I wanted to go there and never had an excuse. Now I had an excuse, namely they were going to give a talk, demonstration about a Gigatron home-built computer, which is brilliant because it's made out of TTL components, not individual transistors, but TTL components. Uses an EEPROM, or I think an EEPROM for ROM, and a normal parallel RAM. But it generates a VGA image. And I thought the hardware and the software design especially was very, very interesting, because what they did was make an interpreter on top of the hardware, so you can write in a reasonably high programming language. And actually they made a game for it, and text output and a demo and scrolling stuff on the screen. It's really, really nice. Talk with the people there. This kind of stuff gives me a lot of energy, a lot of ideas. So that was nice. Also nice space, very nicely cleaned up. Everything was in the right spot, so maybe I go there again. But it's 1.5 hour drive single way, so not going there often. And that's basically all I did, except spent a bit too long testing a LED driver. That was a chip, never used it before. Now, usually when I see a reset pin being mentioned in a datasheet, and I see pull-up resistor in the same sentence, I automatically assume it's an internal pull-up, so I don't have to connect the reset pin, I can leave it floating. Now in this case there was no internal pull-up, so spent a couple of hours screwing around, getting the chip to talk back, but it didn't, so reset was not being pulled up. So very easy fix, a lot of wasted time. Also what I didn't do was make software for the Commodore 64 cartridge adapter that I'm making. I'm gonna do that at some point, but right now focusing a little bit on getting my stuff ready for the Maker Faire in March in Dortmund, and also regular work. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.